Hello, and I am Dr. Decalin, back to talk to you again about water in fuel, and to advise you, don't let it get in there. But if you have got it in there, part one of this exciting series would have told you how to get rid of it using one of these two products, CH-77 or K100. They're both equivalent in terms of performance. That was in terms of removing water, and now I'd like to talk to you about their effect in preventing corrosion. Now, if the water has got into the fuel and there's any metal in contact with the water, then that is bad news, because corrosion will start. Now, to run the corrosion tests that I'm going to be talking about here, I created a test coupon which is more active than just an ordinary piece of metal. I created an electrochemical couple, and I'll talk about that in a moment. I made my couple out of pure zinc. This is pure zinc riveted with a pop rivet there to a piece of pure copper. There we are. And before I put them into a test cell, and this is the test cell I used, it's a polypropylene, actually a centrifuge tube, but perfect for this job. So you get a good look at it there, just a tube. And into the tube I put 10 milliliters of water. In the first test it was ordinary plain water, actually straight out of the tap, and 10 mils of gasoline. I used 93 octane Chevron gas. We have a Chevron gas station near us. And then that was what I used for the blank, in other words, with nothing else in it. And then for the test I would put 2 milliliters of each of the products, CH-77, K100. For the first test I didn't have any seafoam, so I don't have results for plain water for seafoam. For the second test I used seawater, and I made synthetic seawater, sodium chloride, a bit of potassium chloride, a little bit of other salts, and I didn't drive 150 miles to the sea, to the coast, to get seawater, because I didn't want all the microorganisms that come along with it. I didn't want them messing up the test by growing in the tube. So this is synthetic seawater, but it's got all the evil ingredients that cause corrosion in there. So, having talked about my test coupon and electrochemistry, you might think that this is a modern thing. It's not. It goes back 2,000 years. They, in fact, found a battery in Baghdad, excavated in one of these archaeological digs. This battery from 2,000 years ago. Can you believe that? And this is constructed just the way I would have made a battery back in those days, an earthenware pot with an iron rod in the center, insulated from a copper tube, surrounded it using pitch. Yes, some kind of tarry material, and used citric acid or vinegar as an electrolyte. And I haven't looked up the individual reduction potentials of those, but I would imagine the voltage across that is somewhere around half a volt. And if you put a set of these in series, you could build up a significant voltage. So that's where batteries came from, and way back, long ago, back when I was training for chemistry, we used wet cells in the lab because dry cells were expensive, and we used a Decalin cell. Now the Decalin cell was invented by a French geezer by the name of Georges Leclanche, and it was invented 1886, and very efficient. It was a zinc carbon cell using ammonium chloride, I believe, as an electrolyte, and all you need to do is just clean off the zinc electrode and you're ready to go. Worked very well, used them a lot in physics. So, now you're dying to ask, well, what results did you get? The first results I got when I used only these two products, plus a blank, were like this. This is what the blank looked like. There we are. There's corrosion on that, you can see that. White corrosion. And there's no corrosion on the copper. And this went in according to the scratched on marks. 1/4/19, so that went in January. So that's been sitting in there since January. Here is the CH-77, and the date of this went in February 14th, and it's March the 15th, so this has been in for 2 months. And you can see, although it's stained on the surface, there's no real corrosion. Some kind of dusty staining on the copper, but nothing worth worrying about. So that is an excellent result. And for the K100, you can see that. Now this is somewhat etched. The copper is actually etched. It feels rough to the touch. Actually kind of sticky film on there. In terms of corrosion, that is quite a good result. That's quite a good result. So both CH-77 and K100 do inhibit corrosion. So you could expect, when using either of those two products, much less corrosion than you might otherwise get. So both of these are neck and neck in terms of corrosion in plain water. Well, for you seafaring folks, you are interested in what happens when you get salt water in there. Boy, you don't ever want to get salt water in your fuel, let me tell you, after looking at these corrosion results. Because this is after 30 days. This is the blank. See all that horrible white gunge on there? Chemically, that will be zinc hydroxide. And if zinc hydroxide is exposed to the air, it will absorb carbon dioxide, and then it will go dark and form zinc carbonate. Here is the CH-77. Let me get the blank for comparison. Yeah, you can see both of those. And there's a little corrosion, but not very much. Blank in blank. And here is the K100 compared to the blank. There is the K100. it has blue deposits on it. And what that means is that the copper has been dissolved into the solution and has redeposited on the zinc. You can see the attack on copper. That's that orange colour. That's what's happened there. Some of the copper has dissolved and deposited on the zinc. That's why the deposits there are a greenish, bluish colour. Hope you can see that. So, not quite as good a result, I think. If I had brass innards to my carburetor, then those brass innards may get attacked in a seawater environment. And those of you who deal with this will probably be saying, yeah, I know, it corrodes like crazy. Well, this would help some of it. However, the CH-77 looks like it may do a better job. And here is the Seafoam. There's the Seafoam, this one. And there's the blank alongside. There's no difference. They're the same. So Seafoam does absolutely nothing in terms of preventing corrosion. Seafoam, there we are. I actually scratched on the copper what these were so I wouldn't lose track of what was what. Bottom line is, these two do a reasonable job of preventing corrosion in fresh water, and they both do a kind of okay job in seawater. Seafoam does nothing. I mean, I know from what I see reports of, especially on Project Farm YouTube channel, they got excellent results with Seafoam in freeing up stuck piston rings and restoring the performance of a tractor. So if that's your need, then that's the product. Now both of these have the kind of ingredient that is in there to do that same job. They also remove water and they also inhibit corrosion. What else can I tell you? The active ingredient that does that is called an organic amine. It's a complex organic structure with an amine NH2 group on the end. It has to be of a very special structure to work. But as a formulation chemist, I know what those are. What else can I tell you? There's a carburetor I took off my snowblower. I was tempted to throw it clear across the yard because it's total junk. And because of all the corrosion that occurred inside, I had to put a brand new carburetor on. And that's one of the reasons why I've been prompted to do this research and development. So there we are, carburetor. While I was doing these corrosion tests, I was logging and weighing these coupons. Oops. I was weighing these coupons on this analytical balance here, and this will weigh down to 0.1 of a milligram, and is extremely sensitive, so I could record any change in weight. Now let's see if I can find a good, let's start with this one. This is with the plain water. I'll bring it up to you. This is with the plain water. This is the blank. This shows that the blank, this is day 1. These are days here. And this is the weight change, the weight change from when it was first put in. And you can see on the first test date, 6 days after I started, the weight of the coupon went up by this amount, like 0.15 grams, and 150 milligrams. And then it steadily deteriorated. My guess is it actually remained constant because the corrosion was so heavy on the surface that the corrosive chemicals couldn't get to the metal surface to corrode it any further. The CH-77 also increased in weight by nearly 300 milligrams per coupon, and remained pretty much constant. So it appeared that the surface acquired a layer, and my guess, my shrewd interpretation of that, is that it acquired a layer of the corrosion inhibitor material that is part of the formulation, and I know exactly what's in there, but I'm not going to tell you. And for the K100, the opposite happened. There was an immediate loss in weight with a progressive increase in loss. It was losing like, it started off losing roughly 200 milligrams and then went above 200 milligrams here. The Seafoam, it lost a lot immediately, over 400 milligrams per coupon. It lost immediately and progressively lost more as time progressed, and that was in there for, how long is that? About a month. So it was in for about a month. So this is the result of the freshwater test. Now for the seawater test, let's see. Let's start with the blank. For the seawater test, the blank, yeah, it's over about a month, the blank lost 500 milligrams right off. That's a lot. That is a lot. And progressively increased the loss. The Decalin CH-77 gradually increased in weight. It didn't decrease, it increased. So what was building up on the surface, and remember I wiped off the surface before I did the weighing so that the corrosion was not weighed with it. That is, those white deposits. It gradually increased in weight. I could surmise that the thickness of the protective layer was gradually increasing over time. Certainly the coupon was not decreasing in weight, and it didn't visibly look any thinner. This is in seawater, remember. The K100, initially, for the first 7 days, it lost weight. The K100 in seawater, it lost weight. And then it progressively increased in weight. I could assume that whatever is in K100 to provide corrosion protection was gradually building up on the surface, and that would account for the increase in weight. The Seafoam, oh dear, it lost weight right out the chute from day one. 30 milligrams, and then progressively lost weight as the days went by. I'm afraid Seafoam, despite the name sea, doesn't do anything in a seafaring environment in terms of preventing corrosion. And that is about all I have for you. apart from talking about price of these products, I forget what I paid for the Seafoam, but I paid $30 for that quart, thereabouts 31, something like that, plus shipping. And for the CH-77, the Decalin product, I paid $15. So it's half the price. In terms of water removal, they are neck and neck. In terms of corrosion protection, they are very similar. They both behave in a similar fashion in a corrosive environment, substantially reducing the amount of corrosion you get. And if you're watching your pennies, that's the product. One other comment I would make about this: similar formulations from Decalin are used in aircraft engines. They're used in the fuel that go into aircraft engines. And in fact, I have a light aircraft, and I put Decalin products in my fuel. And because if you're 5,000 feet up in the air flying along over the mountains, you don't want that engine to quit on you. And so it's safe in an aviation environment, and also works for diesel. I demonstrated that it does work for diesel. What can you say? Good stuff, definitely works. If you want a well-known product with demonstrated performance and you're prepared to pay the price, then that's what you want. I hope this has been a fair and unbiased report. I did my best to not introduce bias in any of the results. What you see here is what I've seen, and I'm very, very pleased with the results and the way they came out, because believe me, I've done a lot of these in the past, and these corrosion tests are difficult to carry out, and to separate results such that you get results that you can interpret, one being different from another, is really hard to do. So these tests have come out very well. If you like what I've presented to you, then ring that bell, subscribe to my channel, Dr. Decalin, and hit the likes button. And that's about it. Until the next exciting episode, I'll see you.